Good afternoon. It's kind of strange to say it given that it's the middle of April, but welcome to the beginning of Excel recruiting for the year. We've been doing Excel recruiting for about 10 years. This may actually be the 10th year. And one of the things that's been really nice about the program is we can bring in people who bridge different areas and go outside of sort of standard groupings. And today, I think we've got a very good example of that. Today, we're going to be hearing from Akane Sano from the MIT Media Lab, who's done some really creative work going from sensing systems on DSPs to persistent health monitoring to how do we get better sleep and what is the stress doing to all of us. So I think many of you can actually relate to that. So I'd now like to introduce Akane.
Thank you. Thanks for introduction, Scott. And thank you, everyone, for coming here. I'm very excited to talk about measuring sleep, stress, and well-being using wearable sensors and mobile phones. First of all, I want to ask you questions. How many people have mobile phone here? Thank you. And how many people have experience in wearing wearable sensors? Thanks. So let's imagine your mobile phone and your wearable sensors tell you not only how many steps you walk, also how long you sleep, but also how you can reduce your stress and also give you a personalized warning before you get sick. So this figure shows you how our well-being changes with a lot of stress with time. So some people can be resilient with a lot of stress, but that's not everyone. You know, some other people, unfortunately, their well-being is declining like this. And once we come, this area is really hard to come back. So today I'm going to mainly talk about the people around here, like people who are resilient, also people whose well-being is declining like this. So what I want to talk about today is, we want to do here is, before this declining happens, we want to know, why this happens and how we can help people being resilient. So let's think about this example. Mental health and well-being is one of the most challenging issue in our society. So, for example, depression is one of the major issue, and depression will be increasing, and by 2020, it will be the #1 disease caused. So what we want to do here is, how can we identify factors related to our stress and mental health? And can we predict how we are feeling, not only right now, but also in the future, so that we can prevent this declining is happening? And eventually, can we help people to change behaviors to improve their health? So my vision of research is the following. So I'm very interested in understanding relationship between human behaviors and physiology with health and well-being through human data analytics. Also, I'm very interested in designing tools and practical systems for measuring, improving health and well-being and preventing diseases. Especially, I have been working on measuring, understanding, and improving mental health and well-being in relatively healthy populations exposed to very high stress and low mental health. So a lot of previous studies have been focusing on comparing healthy populations and patient populations. And this is, of course, important because we want to know how these two populations are different. However, if we look into only relatively healthy populations, probably like us, like active college students, office workers, they have also some problems. Because if we think about ourselves, our health and well-being is also changing and has a lot of ups and downs. And they are exposed to high stress and low mental health condition. And if we think about our data, about 50% of our participants they have high stress. And 50% said they are poor sleepers. And unfortunately, 25% reported regular sadness. And 80% has lower mental health than average. Do you have any questions?
Was this population selected for these variables, or did this population just have these variables?
Oh, so this is the population we have been studying in our study. And so what's your question?
I was questioning, 49% seems really high for sleep, so it sounds like the population you selected does have a lot of stress rather than you picked them because they were stressed.
Oh, actually, we are not choosing participants because they are poor sleepers. We are randomly, I mean, we have some selection bias, of course, but we are randomly selecting our participants. So in our study, we use multimodal data set. For example, our personality type is a very big contributor to our health and well-being. So for example, if you are neurotic or not, whether you are like extrovert or introvert. So if the same things could happen to me or to you, person A, B, C, everyone perceives things very differently. So something can be very stressful for you, but not for everyone. And in addition to personality type, we have other components such as physiology, behaviors, environment, and social interaction could also influence our health and well-being. So think about if you have a problem with your boss or with your family, that could influence how stressed you are. Then recently, we have a lot of devices on the market, a lot of wearable and mobile devices on the market that can allow us to measure like 24 multimodal time series data. However, it's still very hard to interpret what's the meaning of the data. So in our study, we are very interested in how we can leverage this kind of 24/7 multimodal data from wearable and mobile devices for improving, like measuring and improving our health and well-being. So today I'm going to talk about mainly this study called Snapshot Study. This is a collaborative study between MIT Media Lab and Harvard Medical School. And so we are aiming to measure like sleep, network, affect, performance, stress, and health using objective techniques. So in the study, so we are using mobile phones and wearable sensors, as well as laboratory measurement. And this brings us very rich, long-term, and large-scale data set. So since 2013, we have been running this study every semester to collect large amount of data from relatively healthy populations, including like sleep, exercise, light exposure, and stress, autonomic stress responses, as well as how many text message, phone call you make every day, because this gives us information about what kind of social network you have, and mobility patterns from your GPS. And using this data set, we have been working on how we can predict, how we can estimate how you are feeling right now, but also how you are feeling in the future. Then also we are also working on designing interventions to reduce our stress and improve well-being. So in the study, so far we have been collecting data from about 300 participants. And right now, in this semester, 2017 spring, we are extending this study from 30 days to even longer, 3.5 months study. So now we are in the sensors and joining our study. So then we also recruit people who are socially connected, because we are interested in how their social network influence their health. And over 30 days and this semester, as I said, 3.5 months. So they are wearing sensors to measure physiology, activity, light exposure. And they install the mobile phone app to their Android phone to capture phone call, SMS, screen on, application usage, location. And they fill out morning and evening daily surveys about their activity and feeling. They also participate in this laboratory study for circadian rhythm measurement, performance, and stress and mood test. And here is one example of our social network. So this is a visualization of the data from our cohort in 2015 spring. And here you can see how each dot is one participant. So you can see how these people are connected over SMS. And we overlay this information, SMS information, with their mental health score. Then here I want to talk more about why we care about their social network. And this is one example of very famous study run by Christakis and Fuller. And they use some social network data from Flemingham's heart study, which is the long-term study running in west part of Massachusetts, Framingham. And their analysis shows that happiness spread over social network. That means if you are surrounded by happy people, you will be also you will be highly likely to be happy as well. And do you think this happens to you before? No? And their finding is not only applied to happiness, but also other things like loneliness, depression, sleep behaviors, obesity. And in this study, so they have been using paper-based surveys to log how these people are connected over 20 years. But in our snapshot study, we are using objective techniques, for example, like phone logs and email logs, to capture their social network pattern objectively. And this is the reason why we care also social network patterns, because social network, how you are, whom you are connected with, matters for your health and well-being. Okay, so next time I'm going to talk about how we process our raw data and process features, then eventually do analysis. So as I said, we have been running this study since 2013. And so in the study, so we meet our participant on day one. Then we explain about how our study is, and if they agree to join the study, they are with us for 30 days or 3.5 months. Then it's so we give our sensors to them, so they start wearing the sensors, and then we see you in 30 days or 3.5 days. And this is not like this. So if we do like this, actually the human experiment, long-term experiment doesn't work well. So instead, what we are doing is we need to continuously validate the data coming from our participant. Because think about a lot of devices they are wearing, like 2 wearable sensors. They are also running our mobile phone on their mobile phone app on their Android. So we need to constantly check, validate whether we are getting clean data, because during the study, sometimes the devices can break. Our wearable devices can break in the middle of the study, and the phone might stop working. Also, sometimes our participants forget filling out surveys. So we need to automatically check whether we are getting the data properly. And if that doesn't happen, so we build a system that automatically sends notifications to our participant as well as us, study investigators, so that we know that the study is going on properly, or we have to tell them that, oh, you're not filling out surveys for a few days, so are you still interested in the study? Or your device might be not working, so we need to replace the new devices. Also, in the study, we are collecting the data from wearable sensors, and the data itself is pretty noisy because the data we are collecting is like 24/7. That means when they are like running or typing or doing whatever they want, we are always collecting the data. That means the data is pretty noisy. And we need to figure out which portion of the data is clean and which portion of the data is not clean, so that we can use some of the data for further analysis, and we need to discard some of the data set. And here I show some examples for our skin conductance data from our wristband sensor. And skin conductance, this is a autonomic nervous system responses. And this is one example of the data for a few seconds. But in our data set, you can see this kind of noise. Sometimes our sensor moves on our skin, and if we see this kind of noise, even though we apply some filtering, that doesn't work. So instead, what we did is we made a binary classification models to detect artifact. So with the data we previously collected from previous studies, we asked the experts to annotate the data and which data is clean and which data is not clean. And then using the time and frequency domain features, and we made this binary classification model. And with this model, so after we collect the data, we can see, oh, this data is clean and this data is not clean. So we can't use for further analysis. Okay, so far I briefly talked about how we collect this raw data and process. And next I'm going to talk about some analysis and modeling. And since our study is like 30-day and 3.5 months, like long-term study, our analysis can be about like short-term, like acute stress, also more like long-term chronic stress and sleep behaviors. So today I'm going to mainly talk about these three things. First of all, long-term mood sleep analysis, ambulatory sleep detection, and daily mood prediction. So this is the data from our cohort, a 2014 fall cohort. And x-axis is time, day 1 to day 30. And y-axis is self-reported happiness, calmness, alertness, energy level, and health from 0 to 100 scale. And this is a grand average of overall participants in this cohort. And here you can see some trend. For example, these participants are much happier and also calmer on weekends, like Friday, Saturday, Sunday. They are much happier. And I want to show you one more graph here, this one. On the right panel, I show the data from one participant in the same cohort. And you can see the difference, right? So this participant, actually, unfortunately, she went to a hospital. She hospitalized during the study around this time due to her mental health issue. And you can see a lot of ups and downs in her data. And if we plot our sad and happy average, happy, sad mood, like this x-axis is the averaged mood over 30 days, and y-axis is mood variation, standard deviation of our mood. And we can see this kind of plots. And roughly, we can see like about 3 different clusters. And this red cluster is happy group, and this blue cluster is a sad group, and black is like medium. And we can see this kind of trend. So that means like sad group, they have much more mood variation every day. And if we look at this sad group has much statistically lower poor sleep quality. Also, they have higher sickness. They also use their phone late at night. Also, they have a higher sluggishness, higher stress level. So they have much worse health outcomes. So next time we're going to talk about how our long-term sleep patterns influence our health and well-being. And this is a 30-day sleep patterns. So x-axis is time from midnight to midnight on the next day, and y-axis is day 1 to day 30. So you can see these black boxes are when they go to bed and they are sleeping. And this is the plot from the most regular sleeper in our cohort. That means this person went to bed and woke up at almost the same timing. And whereas I want to show this one, can you see the difference here? So this is the most irregular sleeper. That means this person has very random bedtime, wake-up time. Also, we can see a lot of naps during afternoon.
How was the sleep recorded?
Sorry, I couldn't hear. How does this sleep record?
Was it manual tracking, or did you use the wearable sensor?
So we use both. So we use wearable sensors that can track our activity patterns, and so that can tell us approximately when you went to bed and woke up. Also, we ask our participants to fill out sleep diaries. So if we compare these two groups, how does the sleep regularity affect our health and well-being? And here, instead of looking at correlation, we want to look at more like causal relationship. So here, what we did is we controlled like gender, sleep duration, stress score at the beginning of the study, so which are the factors that also related to well-being. So we need to control this factor to figure out how sleep regularity really affect our well-being. And what we found here is, can you guess what you will see here? So irregular sleepers shows much lower mental health and lower happiness, alertness, and energy level. So even after controlling for some factors that could be also related to these factors. So next time we're going to talk about ambulatory sleep detection.
Sorry, what were the causal conclusions from that last slide?
So our conclusion is irregular sleep affect like lower mental health, happiness, alertness, and energy level.
Could it possibly go the other way? That those things affect your sleep instead?
That could be, yes. Actually, we didn't analyze that direction yet, but yeah, that could be possible. But here we control like sleep duration, for example. So what we saw here is rather than actually sleep duration, like sleep regularity matters more. Okay. So next time I'm going to talk about ambulatory sleep detection. So we all know that like accurate sleep detection is super important in sleep project and health-related project. However, maybe some of you know that the ground truth of measuring sleep is not useful at all. So you know this polysomnography, PSG, is a gold standard to measure sleep. But you have to wear a lot of sensors to measure brainwave, muscle activities, etc., heart rate. And this is not practical at all. So we can't ask our participant to wear this for 24/7 for 30 days, right? Then instead, So in our study, we are using another gold standard to measure sleep in sleep studies, which is actigraphy and sleep diary. Actigraphy is like this, like wristband sensor with accelerometer and light sensor. But this is also a problem, because if our participants keep wearing this and keep filling out surveys, of course they have to keep diaries every day. And us, study investigators, we have to check their answers every day, whether they are accurate or not. So that's why there is a great need to develop accurate, long-term sleep detection system, which is a less burden for users and also less burden for study investigators. So that's why here we decided to develop our algorithm, sleep detection algorithm, using sensors and also mobile phone data. So you can see some example of the data here from wristband, like skin conductance, skin temperature, and acceleration. And we also plot some data from mobile phone. And these red boxes are when participants went to sleep. So you can see, for example, like screen. This is a screen on/off logs. And you can see screen is completely off when this participant went to sleep. And here we have two tasks to do. And the first task is we want to detect whether you sleep or you are awake over every 1 minute. And the second task is also we want to detect when is the beginning of your sleep and the end of your sleep, because this information gives us how long you sleep and how well you sleep. So we use this multimodal data from sensors and mobile phone, including skin conductance, acceleration, skin temperature, screen, SMS, phone call, location. Also, we use time as features as well. And for the first step, so in order to detect sleep, we use this bidirectional long short-term memory neural network. So using your previous 30 minutes data plus future 30 minutes data to estimate your condition of the current time. And for the step 2, in order to detect sleep onset and offset, we use this cross-correlation-based template matching method. And here is the results. So if we combine the features from acceleration, skin temperature, and time, so we can detect sleep-wake with 96.5% accuracy. And for sleep onset and offset detection, we got this kind of 0.85, 0.82 F1 score with mean error about 5 minutes. And these accuracy are much better than previous studies. So next time, we're going to talk about the prediction of our mood. So one of our interests in our study is we want to estimate how you're feeling, not only right now, but also we want to predict how you will be feeling like tomorrow, like next week or next month. Because remember, one of our interests is we want to know, we want to predict before you will be sick, right? So that we can provide proper advice or interventions so that they can stay healthy. So here, our question is, can we predict a person's mood tomorrow using today's data? But here, we have very important problem. Because think about what makes you happy. That might be like going to a party or going on hiking. So what makes us happy is different from people to people, right? So let's think about this example. Like person A, this person, she is pretty happy with working in the lab. but she's not happy if she goes to a party. But this is not everyone, you know. Person B, yeah, she's pretty happy. She enjoys going to a party, but she doesn't work in the lab. So how can we consider this kind of individual differences? So here we use like multitask learning. This is one kind of machine learning model that allows us to train a model tuned for some people while still learning the model from the rest of the participants. So here, we are trying to predict our mood. So this is a binary problem. Like we want to predict whether your mood is high or low based on your today's data. But we still have another problem. Ideally, we want to make a model for each individual because everyone might be different. However, some people are always like happy, like always sad. So some people have only labels for one class. So we can't apply easily, this model for everyone. So instead, making a model for each individual, here we use k-means clustering method so that we can cluster some participant who has some similarities in their personality types or characteristics, so that we can still apply this multitask learning to different clusters. And here we use this k-means clustering method and clusters our participants using their pre-study survey characteristics, including like stress level, mental health score, sleep quality, and personality type. And we found 2 clusters are the best in our data set. So one cluster has a little bit lower mental health and fewer happy days. So if we don't account for like individual differences, and if we just generate only one model that can be applied to everyone.
So is there a concept of, so you have these 2 classes.
Mm-hmm.
How do you know it's 2 and not 4? And do you have any intuition on what makes a person be in one of those classes versus the other?
So do I have an intuition?
So first off, how do you know it's 2 that's the right answer for this instead of 6 personality types?
So here, yeah, we use this silhouette score to identify what is the optimized number of clusters, but this can vary for different data sets. For example, if we keep collecting a larger amount of data, that can be like 5 clusters or 10 clusters.
Okay, so it's a function of the size of your data set. Is there some feature that explains the 2 different groups? Is it introverts versus extroverts, or engineers versus English majors, or what have you?
Yeah, so that can be possible. Here, we didn't include the information about, for example, their majors or their jobs. So we use this information. So one cluster is like a little bit happier than the other. So their personality type will be different. So here, what I was going to tell is, if we make only single model that applies to everyone, we got 60% accuracy in predicting tomorrow's mood using today's data. However, as I said, thinking about this individual difference is very important. And if we take account for these individual differences, we got 76% accuracy in predicting tomorrow's mood. So we have been working on this predicting health and mood using previous data, using different algorithms as well.
Excuse me, in Seattle, the mood is very highly affected by the weather tomorrow. So what are we going to do? No matter what kind of mood I have tomorrow, if it's sunny, I might be very happy.
Yeah, that's a good point. So here, actually, we incorporated some weather information as well. But we use weather information from today, so previous days. So we are not using the weather information for tomorrow. But if you think about, yeah, it's going to be rainy tomorrow, so you might start feeling like sad. So tomorrow's like future information could also influence how you're feeling. Okay, so far I have been talking about our observational study, like a snapshot study we have been running at MIT to study like what kind of behaviors are related to our health, especially our stress and mood, and how we can not only estimate how you're feeling right now, but also how we can predict how you'll be feeling in the future. But I'm also interested in how we can help people to improve health and well-being. So next, I'm going to talk about some of the latest latest research project about improving health and well-being. And this is a project I have been working with people at Microsoft Research. And idea is we want to provide some micro interventions to people who are working on computers, like office workers. Because sometimes they are too focused on using computers, and sometimes they forget taking a break. So we want to provide micro interventions like this. Yeah, why don't you take a break and try like breathing exercise, or why don't you take a walk? And also we provide some advice about like sleep, diet, and exercise. And this system is, so we built this system using like wearable sensors that can capture their activity and sleep information. Also, we capture how they are using their keyboard and mouse. And this information goes to the cloud and try to feed back personalized information. And here, there is another thing we need to consider, because we don't want to bother our office workers by providing this intervention, this feedback in a very bad timing, right? Yeah, think about if you are really you have deadline and working on something to finish, then you don't want to be bothered by this kind of system. So we need to understand when is a good timing to provide intervention. And another project we have been working at MIT is the phone app that helps you to do self-mini experimentation. So some people might be curious that, so what if I sleep like 30 minutes more? And what if I sleep 1 hour less? So how about other cases like, yeah, how my productivity changes if I sleep 1 hour longer? Or if I move 30 minutes more, does it affect my sleep efficiency? Sorry. So this app can help you to do this kind of experiment by yourself. So here you select what kind of experiment you want to try. And if you choose one experiment, like over the next few weeks, every day you will see this kind of instruction. For example, today, try to go to bed at 1:20 a.m. And tomorrow you might see, try to go to bed at 12:30. Then at the end of the self-experimentation, you might be able to see which parameter, which behavior is the optimal for you to maximize, for example, happiness or reduce your stress. So we have been running the user study, like 6-week pilot user study to evaluate how our participants are using this kind of app and what kind of things they like, they don't like. And yeah, I want to also show this kind of graph. And this is a graph from our snapshot study. And the top one, this is the stress student behaviors. And bottom graph is calm student behaviors. And x-axis is time from midnight to midnight. And you can see how many percentage of students are spending their time on different activities. For example, during nighttime, they are sleeping, and during daytime, they are taking a nap or doing academic activities and exercise, etc. And if you look at these graphs, can you see the difference? Can you see the difference between two groups? And answers are here. So stress students, they take naps in the late afternoon, and calm students, they take study breaks around noon, and they go to bed early and wake up early as well. So if you look at this kind of graph, what do you think? Does it help you to think about your behaviors? And do you think, does this help you to change your behaviors? So our hypothesis is showing this kind of social comparison might be able to help you to think about what kind of behaviors you have compared to these two groups, and what's the difference between your behaviors and these behaviors. And you might want to try changing your behaviors to be like less stress, calm people. So I briefly talked about some of the recent projects about improving health and well-being. So lastly, I'd like to talk about the future directions of my research. So what I want to do in the future is I want to design practical systems for improving our health and well-being. So what I'm imagining is like this. So we have these people here. So we want to capture the data from people using like wearables or mobile devices or any other type of sensing system. And then we want to provide some useful, like personalized feedback to users in a very effective way. Then here, I want to talk about three things. So first one is, so I want to extend this kind of snapshot study to the next level. So I want to run snapshot study 2.0, so that target like even larger scale and long-term ambulatory study, and including people in remote locations. So then I'd like to develop and test personalized health and well-being prediction and also intervention systems. And I'm also interested in not only studying like students, but also office workers, but also other populations, such as like elderly people, like drivers, and also patients. And so, for example, like elderly people, they might not wear sensors, wearable sensors, but we can think about other kind of measurement system. For example, we can embed some sensors into their home setting. I know some of the project has been going on here as well, but I'm very curious. I'm very interested in how we can incorporate other type of sensing into their home setting. Then how can we study, for example, their cognitive performance? Like how can we detect their cognitive impairment before that gets worse? And not only cognitive performance, but also like for office workers, we can also study productivities and engagement. And second thing that I'm very interested in is not only developing the personalized tools, but also designing like environment and society to improve our health and well-being. So this can be like writing or some office or school itself or city, and how can help people to be engaged in changing their behaviors and improving their health. And for this purpose, of course, I know that we need not only technology, but also like user-centric design and thinking to translate what kind of things they are missing and what kind of things they need and how we can incorporate our technology to help them. And lastly, empathetic intelligence system. As I said, running long-term human study is not that easy because not everyone is motivated to be healthy, to stay healthy. Some people might be, but not everyone. So how can we engage our users, our participants, in this feedback loop system so that they can enjoy being in tract, being in the study and getting useful information so that they can improve their health and well-being. So in our study, snapshot study, we are paying pretty good amount of money to our participants. And that is the big motivation for them to be in the study. And the snapshot study itself is an observational study. So we want to collect cleaner data and a lot of different multimodal data for long term by paying money. But paying money is not sustainable if we think about practical systems. So we need to think about how we can engage our participants into this system, right? And for that purpose, one of the things I'm very interested in is, can we use like physical or virtual agent into the system so that our users can communicate with that physical or virtual agent so that we can also know what they are doing, what our users are doing and feeling, and also provide some effective personalized feedback. So this is the graph I showed you at the beginning of my talk. So I've been very interested in how we can design practical systems for improving health and well-being, and ultimately preventing our diseases. And so I'd like to continue this kind of scope of the research for the future. And this is the end of my talk, and I'd like to thank my awesome collaborators and colleagues at MIT and Harvard, Microsoft Research, and I'd like to also thank some funding resources that made our research possible. And I'm happy to take any questions. Thank you.
So I'll throw out the first one. You had a theory in what you were doing that if people saw data, it would help them improve what they're doing. You've seen a lot of data on this. What have you done to improve your health based upon what you've seen?
Yes, that's a good question. I have been doing a lot of self-experimentation by myself because whenever I start a human study, the first subject is me, right? I wear a lot of sensors and try different systems I developed. And I have been learning a lot of good things about health and well-being. So I have been sleeping very well every day, even though I'm pretty busy. So sleep is very important for me. And
Cool. Way back.
Being from MIT, I applaud this effort. This is pretty important for the students. But I guess I was wondering, how did you convince students to give you access to like when they sent their emails and their text messages and when they opened their phone? Like, was that difficult? And did you have to put special like security measures in place in order to store that data?
Oh, so are you asking about when we collect the data and
give you access to all this information, and then how did you keep it secure?
I see. Okay, thank you. So of course, everyone might not want to join this kind of study because we are collecting a lot of data, right? And so we are not collecting the data from everyone, only from people who consented to join the study. And as I said, many of our participants might be motivated because of money, or some people are very interested in quantifying themselves and also knowing more about them. And then another aspect about like how to store the data, how to share the data. So we de-identify, of course, all the data, and we use all like de-identified data for our analysis. And some of the data we are collecting can be very private, for example, like location data. So we only use like some process data, like features. So we can't visualize each individual's like specific locations. I showed some of the visualization, but this can be mostly like aggregated data, and I didn't show any like specific location data for each individual, right? So I'm not allowed to do that. So then also the data is stored in like password-locked machines. And
was there any feedback given to the participants during the study? Like, did they get to see the different correlations between what the activities and sleep, or was it only accessible to the researchers?
So in the study, we are not providing any feedback because we don't want to intervene them for this purpose, because the snapshot study itself is an observational study. So, but we did some like follow-up study for some of our participants to show some visualization of their data, then ask them how they feel about, whether that kind of visualization might like help them to think about their behaviors and change their behaviors. So we have some umbrella studies under the snapshot study, but overall for everyone in the study, we are not giving feedback.
I guess I had two questions. First, about the underlying motivation, like well, first, mental health is obviously important, and doing anything to help people with mental health problems is really important. But it seems like part of the motivation is to increase happiness for everyone, and I'm kind of wondering where that comes from. And like, it seems like a very Western value that may or may not actually be what's best for everyone, right? Like maybe it's okay to be sad sometimes or depressed sometimes. And then the second question was, I'm assuming that your participants were from MIT or Harvard, which is a very unique population, and I know there's a high suicide rate and things like that. So I'm wondering, I don't know, maybe your participants are not the typical sample, or like how do you think your results generalize? Maybe participants are more resilient to stress because they've learned to cope with it, or less, or I don't know.
Yeah. So for your first question, I think the maximizing your happiness can be a big, very interesting topic for almost everyone, I think. So you might not want to optimize your behaviors every day. That means, you might not want to keep only eating healthy food every day, right? But sometimes, of course, you want to eat some chips, ice cream, or, you want to be lazy, I mean, we can be lazy sometimes. But with those kind of some variation of your behaviors, but ultimately you want to be like healthier than, or like happier than like sad. No? Don't you think so?
I don't know, that's my question. If that value came from the subjects, that people just want.
I think, for example, everyone has different definition of happiness, I think. Some people cares about one thing. I don't know, some people cares about like GPA, or some people cares about hanging out with friends, or family, or different things. But I think everyone is interested in happier, and then happiness affects so many different things in our life. And so that's my answer. And to the second question, sorry, what was your second question?
MIT population
Oh,
versus
yes,
normal.
that might not be generalized. Yes, that's a good point, yes. So I wouldn't say these findings can apply to any other people in the world. And yeah, this is the data from, very limited region of the, and so, and also still very limited amount of data set. And so I don't think that, this can be generalized to anyone else. But I think still this is a starting point to continue this kind of study. And so I'm hoping to scale this kind of study up and for different populations and for different target.
Do we have a last one?
Have you considered doing like targeted interventions to kind of understand the causal mechanisms a little better? So telling someone go to sleep at 12:30, see what happens, and doing it randomized and things like that. Have you considered doing things like that with your snapshot?
Yep. Yeah, I think that's also interesting approach. So in this snapshot study, we have been running observational studies, so we are not doing randomized control trials. But we could also do randomized control trial on the next step. Or also we can do self-experimentation study for big N.
Cool. Thank you.
Thank you very much.